Microphone check 1 2.
Bruh.
Hit me with a bruh if y'all can hear me. It's your boy the network.
Bruh.
I'm back in the building with another video. Y'all know I'm using my favorite application, Boson NetSim. Today we're going to be moving on to BGP today. We're going to do a basic BGP lab. Still don't feel like we did a real deep dive with Ospf, so we may revisit some labs from Ospf. Maybe we'll do some more freestyles, break fix some Ospf stuff, because I feel like Ospf came and went, even though we did it for like 3 weeks straight. So and that was a mix between some labs from Boson NetSim. We did a freestyle with Ospf. What else did we do? I believe we did some labs from the lab manual, the Encore lab manual from Ospf. Let me bring up that sheet and kind of go over that. In the meantime, hope you guys have Boson NetSim. If not, then make sure you subscribe to this channel. Hit me with that like button, because I'm going to be giving away a copy of this application. As soon as I get to 5,000 subscribers, I'm almost there. I know I've been saying that for a while. So if you want me to give it away, make sure you subscribe to this channel or spread the word, so that way I can get to that get to my goal. What was that? Let's go pull up. Oh, that's what it was. The study sheet. Like I said, I've been haphazardly following this study plan here. And in case it's the first time you're tuned into this channel, make sure you make sure you join my Discord server. This is the invite right here in the chat right there. So, and this is kind of the study sheet we've been following. Let's see, we did a lot of Ospf stuff like the past, I want to say 2 to 3 weeks. So, the thing is, the Ospf stuff, there's various GNS3 labs. We did a lot of spanning tree probably like last month, so that's why that's all highlighted in green. This is the Ospf stuff. So I want to say we pretty much did all the Ospf labs in Boson, but there's some that was the Encore ones. Let's see what we covered so far. That's the lab we're going to be working with today, by the way. Let's see, all the ones in the green check mark is what we did so far. These are all Encore labs, and these are the Ospf ones. Now, if we scroll down to the NRC, we did one of the Ospf labs in NRC. Here's another Ospf. There's a couple more Ospf labs. So maybe we can go back and forth between the NRC and Encore labs. Y'all let me know if y'all want to do that. But what I ended up doing was just kind of going in order here for Encore. And the next thing we did we did this troubleshooting lab on the last stream. And now the next one is pretty much BGP right here. So I don't know if y'all want to kind of mix it up and go between Encore and RC labs in Boson NetSim. However y'all want to do it, man. Y'all know I'm just kind of going through this. I don't really have to. My shit don't expire until like the end of next year. So I got time.
Bruh.
We got Dave W in the building. Appreciate you for tuning in, man. We got Foster in the building. Appreciate you for tuning in. I'm just giving it some time for some people to tune in. I was waiting on y'all to. We got Professor Black Ops for the stick of the day. You haven't given us that in a while, man. Stick of the day. Y'all know what those are, right? Security technical implementation guides. The Cisco BGP router must be configured to enable the generalized TTL, or time to live, security mechanism, also known as the GTSM. GTSM is designed to protect a router's IP-based control plane from DOS attacks, or denial of service attacks. He hit me with the bros too. Yeah, that's a good fun fact of the day for the STIGs. I did not know that. Y'all know I'm not well versed in my STIGs like Professor Black Ops is. But again, BGP router must be configured to enable the generalized TTL security mechanism. GTSM is designed to protect a router's IP-based control plane from DOS attacks. Y'all know what time and live is, right? TTL. So every hop, when a packet, this is designed to stop loops from happening at layer 3. Let's say we got a packet going from, let's pick this right here. We got a packet from going from here to over here, right? Each hop, this is not really a hop, right? Because that's layer 2, right? So each hop it goes to, the time to live gets decremented by 1, right? So, and usually it's for like Cisco iOS and stuff like that, and and routers, the time to live, I think, is 255. Y'all correct me if I'm wrong. The default time to live, I believe, is 255. And it gets decremented by 1 each hop. So this will be 254. And then that would be 253, 252, 251 from each interface now, not to each router. It's usually to each interface. So that's 1 hop right there. This is another hop right. Well, I like to do it from each interface. But either way, the time to live gets decremented by 1 for each hop. And that's one way to stop loops from happening at the level, at layer 3. And what he said was the BGP router must be configured to enable the generalized TTL security mechanism. GTSM is designed to protect a router's IP-based control plane from DOS attacks. And you know, DOS attack is a denial of service attack. It's a way to kind of like attack a router somehow and render it useless. That's hence the name denial of service. So you can't provide any kind of services because it's been like, you know, like let's say we threw a whole bunch of pings at this router right here. And threw a whole bunch of pings at it, right? And then just rendered it useless, right? And now it can't serve its purpose anymore. That's called a denial of service attack. And I guess GTSM is designed to prevent that from happening. I don't know exactly how it works, but that is the stick of the day. So thank you for that, Professor Blackops. He said Ospf didn't have a lot of checks. That's interesting to know. I want to say because Ospf is not widely used as, say, EIGRP and BGP or whatever. I don't know. I couldn't tell you why. I know at my job, we definitely use EIGRP because they're, and as a matter of fact, the last 2 companies I worked for were pretty much a majority of the network infrastructure was Cisco environment, so they used EIGRP for their internal routing protocol. And then he said Ospf didn't really have a lot of checks. That's weird. I would think, you know, they said Ospf is one of the widely used routing protocols internally. So I would think they would have a lot of checks for that because it's vendor neutral. So you can use it on Juniper routers. Well, EIGRP is as well. So, oh, that's really interesting fun fact there. Anyway, so yeah, this is the lab we're going to be working with today. Configuring basic BGP. This is going to be a basic lab. We should be able to run through this real quick. Maybe we'll knock it out within that hour. Want to read today's news until we get some people to tune in. Y'all know I usually start off at like 10 minutes into the stream. Telegram emerges as new dark web for cyber criminals. So let me read this to y'all, man. I seen this. I was like, I got to read this shit. Growing network of hackers sharing data leaks on encrypted messaging app. So basically, y'all know the dark web it's like the underground circuit for, you know, sharing credit card information and just all kind of stuff. Just really dark. It's just like the dark alleys of the internet, right? The dark web, right? And you can share a lot of stolen information there, and you find like just weird stuff on there, right? So now they got an app that allows you to share this stolen data, like kind of like the Epic breach or like say the T-Mobile breach. They found all of that information and they're sharing it on the dark web. Well, now they got an app for that and it's encrypted. Go figure, right? So it's like the Craigslist for criminals. It's called Telegram. Telegram has exploded as a hub for cyber criminals looking to buy, sell, and share stolen data, hacking tools. New research shows as messaging app emerges as an alternative to the dark web. They got a fucking app to share stolen information. That's crazy, man. And you would think, man, they would crack down on something like this. Somebody has that installed on their phone. Okay, we gonna, you know, track you down. But, you know, I guess they got bigger fish to fry, the FBI and stuff like that. An investigation by cyber intelligence group CyberInt, together with the Financial Times, found a ballooning network of hackers sharing data leaks on the popular messaging platform. Again, it's called Telegram. Sometimes in channels with tens of thousands of subscribers, lured by its ease of use and light touch moderation. In many cases, the content resembles that of the marketplaces found in the dark web, a group of hidden websites that are popular among hackers and accessed using specific anonymizing software. We have been recently witnessing a 100% plus rise in Telegram uses by cybercriminals, said Tal Samara, a cyber threat analyst at CyberInt. And they just go on and come up, you know, with all these facts and stuff like that. It has more than 500 million active users. That's crazy, man. Again, it's called Telegram. I don't suggest y'all download this, but basically, it's like the Craigslist for criminals. That shit is crazy, man. That is just crazy. It's kind of remind me of, y'all remember, I don't know if I'm aging myself with this, but y'all remember Silk? What's it called? Silk Web? Y'all remember Silk Web back in the day? I think it was called Silk Web. It was basically like a marketplace where you could find like stolen guns and credit card information and all kind of shit. But Telegram is just pretty much the app for that. So that's just crazy, man. Crazy. Anyway, hope you guys got Boson NetSim installed and ready to go. We're just going to do the BGP lab so if you scroll down to the Encore section, and then scroll down to the configuring basic BGP routing or configuring basic border gateway protocol, and that's the lab we're going to be working with today. And if you don't have this application, again, make sure you subscribe to this channel. Make sure you hit that like button. I'll be gifting away a copy of this application once I get 5,000 subscribers. I've been saying that shit for a minute. I've been seeing a lot of ninja watchers on my channel, man. Y'all make sure y'all subscribe so that way I can give away this application. Y'all can do this shit with me. So let's go ahead and get started. Task number 1, we're going to be configured as the objective right here. Configuring P1R1 for basic BGP. So P1R1 is the router that sits over here, right here. That's P1R1. And then notice that this is separated in pods right here. It says pod 1 right here, pod 2 right here. So, but when they say pod 1 and pod 2, they're referring to this whole network right here. That's pod 2 and this pod 1 right here. We're going to configure BGP between these two pods right here, but we're going to be doing it via the backbone, which is down here, right? So that's supposed to simulate the internet, I guess. What else they said here? Configure P1R1 and P1R2 for internal BGP. So remember, there's internal BGP and external BGP. Internal is what we use internally within our network, right? And then external, obviously, is for external. So we look at this, or we kind of dissect this network right here. Again, this is P1, pod 1, and this is pod 2. So this would be internally, right? So all of this in here is internal. All of this is internal. So if we configure BGP within pod 1, it's internal BGP. But if we're going to configure BGP between these two, that would be considered external BGP, right? So because they're two, I guess I need to show y'all the BGP topology, right? So we scroll down right here. Pod 1 right here is listed in AS1. And remember, BGP is configured in autonomous systems. So it's like basically a group of routers. So pod 1 is in AS1, pod 2 is in AS2, right? Here's some basic commands that we're working with. We can use this to clear the BGP process. This is similar to clear IP Ospf process, whatever. We do the clock rate command. We've done that a million times on this channel. So basic global config commands and the network and the neighbor statement. Lab task, we'll go ahead and jump right into it. Lab task 1, perform initial configuration. So basically, we got to do some basic IP addressing. Yeah, I'm pretty sure y'all know how to do that. And if not, if you're new to this channel, I typically stream Monday through Thursday, 8 p.m. Eastern Standard Time. Make sure you subscribe. And here is a link to the Discord server. I'm putting it in the group chat right there. He said Silk Road. Yes, that's what it was, Silk Road. Yeah, exactly. So that's what it kind of reminded me of, that application. He said facts. Yeah, both of y'all got it. It goes down in the DMs on Telegram. Yeah, seriously, man. It's just like, hey, man, you want some stolen credit card information? Go ahead and download it over here on Telegram. I don't know if it's for sale or not. I'm pretty sure it's for sale. That's crazy. Dread Pirate Roberts. Yep, double life. Imprisonment, 40 years without possibility of parole. Was he the guy that was kind of like the CEO of Silk Road? I don't remember that guy's name. Dread Pirate Roberts? Y'all let me know. Double life imprisonment, 40 years without possibility of parole. Shit. He should have left like a buddy, what's his name? Snowden did, man. He should have just left. That's crazy. Or was he the guy for Pirate Bay? I don't remember. No, there wasn't no sole proprietary. There wasn't no. That's crazy. 40 years without possibility of parole. That is just crazy. Anyway, what we said here. Oh, so they want us to do basic IP addressing here. So this router right here needs to have that address for the serial interface, this for the loopback, and that for the fast Ethernet. So let's go ahead and do that, right? Y'all know how to do configure IP addressing, right? And if you're new to this channel, you can see this is basic homework right here. So we go to global config mode. If I can type, First, you need to go to enable privileged exec mode. Then you go to user exec mode, or user exec mode, then privileged exec mode. And then you can go into global config mode, right? Enable puts you into privileged. Enable puts you into privileged, and then configure terminal puts you in the global config mode, right? And then we want to configure our IP addressing. So let's start off with let's go from bottom to top. So the fast Ethernet interface first. Probably should have done this before, right? IP address is what? 10.100.100.1, right? So 10.100.100.1/24 subnet mask, which is .0 like that. I don't think we have no shut, but we'll do it anyway. The loopback is 192.168.1.1/28, right? So we got to do the loopback interface loopback 0. His IP address is 192.168.1.1. Oops, .1/28, which is .240, right? We ain't got a no shut that. Interface, what was the last one? Serial 0, and his IP address is 192.168. Oops, 168.1.33 and /28, which is same thing, right? 240.240. Right, so we did all the IP addressing there. What else they wanted us to do? Assign a clock rate of 64,000 to the DCE serial interface. Enable the interfaces. So remember, we got to do a clock rate for serial. So we got a serial interface over here. Well, let's see, over here. And they want us to do the clocking on that side, on this side, right? So, and that's for this guy right here, right? So let's do clocking. I remember how to do that, right? Let's go to interface serial. Oops. Interface serial. Y'all got any questions so far or anything? Anybody lost? Or let me know. I'm gladly answer all the easy questions before we get to even more harder stuff. Clock rate command is how we do it, right? 64,000, just like that. And then that should make our interface come up because we did the clocking. And then let's just verify our work with show IP interface brief. And looks like my laptop is dying. Did I put the plug? Yes, I did. I was like, shit. I would not want it to die in midstream here. Okay, so all of our interfaces are up, so we should be good to go there. Next thing they say was configure P1 or step 2. So we got task 2 with 3 subtasks within that, and then we got task 2 with 6 subtasks in that, task 3. So we got 3 tasks altogether. To configure P1R2, which is this guy right here. So we got to do the IP addressing on this guy. So that interface, and that interface. So again, this is the easy stuff, right? Right? Anybody lost? Anybody got any questions? I know this is the easy stuff right here. He was young too. Documenting was on HBO. Yeah, I'm sure Russia would have definitely pardoned him if he got some juicy intel on the U.S. He sure would have, man. They should have done that, but I'm sure they would have entrapped him or something, man. How to know which side is DTE? Good question, man. If you do show interface serial and then whatever that number is, it'll tell you whether it's the DCE or DCE side, right? So you are wanting to know about, let's see. So we're doing, it's going to be between these two right here, right? That's a really good question. We want to know which side is doing the clocking, right? So we were already on this guy right here. So since I'm already on him, I forgot to do the host name too, right? Configure terminal. So host name, he is R1, and then he's P1 R1. My bad. P1 R1, and then he said he wanted to know the clocking. So interfaces serial 00, and then that's not it. That's not the command I was looking for. It's actually show. Geez, I got to remember that one. That's a really good question. It's not show interfaces serial. It's not show clocking. That's a good question. That's a good question. I like that question, Dave, but I got to remember what that one was. It's not show interfaces serial. That is a really good question. Damn, what was it? It's not show clocking. Show interface serial. Hold on. Interface serial 00, and then is there an output beside that? No, it's not. It is show controllers. That's what it was. I had to go back in the memory bank for that one. Controllers serial 00, and then you space and you scroll up some right there. That lets you know DCE cable. So this is the DCE side, right? was it digital clocking something? I don't remember. This would be the DTE side, right? So, oh, my bad. So data communications equipment. And then this is the data TE side. So data terminal equipment. This is the side that's terminating, right? So it's just to simulate the wide area network, right? So one is, and usually the ISP provides the clocking to you. That's why we really don't need to worry about all of this when we're talking about this from an enterprise perspective, right? So if we go to P1R2 and see the serial interface, let's check the clocking on that. So we go to P1R2 and then enable, let's fix this host name while I'm in here. Host name is P1, oops, my bad, P1R2, right? And then if we say show controllers and then serial 00, and we'll see this is the DTE side. See that? So that's how you can tell which side is doing the clocking. That's a really good question. I like that one, Dave. He said, oh yeah, that was last one. All right, good. So now, since we're on here, we might as well do his interfaces, right? So global config mode, and then we need to do all these interfaces right here, right? All this damn the serial interface, IP addressing for the fast Ethernet, and IP addressing for the loopback. So let's start with the serial interface side. Interface serial 00. His IP address was what? 192.168.1.34/28 subnet, right? Anybody know what the subnet mask is? Written in insider notation is /28. How do you write that in the subnet mask, right? Pop quiz, right? First one that gets that gets a free bruh. 192.168.1. What he said? 34. Subnet mask of. I'm gonna leave that blank while y'all figure that one out. Let's go on to the loopback while y'all figure that one out, right? Interface. Oh, they all got the same loop. They all got the same subnet mask, so I gotta wait on y'all. What is a subnet mask, right? Written in insider notation is /28. What is a subnet mask when you write it out in decimal form? You get a free bruh if you answer that. You, sir, in the back. How do you write that? Oh, that wasn't Dave that answered that question. That was Jacob. My bad. Shout out to Jacob. That was a good question, Jacob. That was a really good question. Foster got it correct. The last subnet, the last octet is 240. So we'll write that back again. 255.255.255.240. So yes, shout out to Foster for that one. My bad, Jacob. I didn't even see you. It's usually Dave that's answering them good questions, though. That's why. So interface, now we got to do loopback. Interface loop 0. His IP address is 182.168. Right? Y'all see that right here? This loopback. 192.168.1.17/28, right? So 1.17/28. Foster said it was .240, right? And then the last interface is FA00, right? So interface FA00. I know we just doing still the easy IP addressing here. 192.168.1.49/28. And Foster said it's .240. Oops, 240. And let's verify our work with show IP interface brief. And then we'll see we got all our IP addressing. Everything's up. Good to go. Everything Chris. And now he said step 3. Step 3. From P1R1, which is this guy right here. Ping P1R2, which is this guy right here, is serial 00 interface 1.34. The ping should be successful. So basically they want to ping from here to there, right? And it should be successful, being that we don't have, this is all virtual. This ain't real cabling and shit like that. So from P1R1, he said ping 182.168.1. What he said? .34? Yeah, .34. Y'all know I got the memory of a goldfish, and we got 5 exclamation points, so we're good to go. All right, so what was next done? Task number 2. Enable basic eBGP on P1R1. Y'all know eBGP, the difference between eBGP and iBGP, right? One is internal, one is external. So again, for those of y'all that just tuned in, right? We said we have these two networks separated in pods. This is pod 1 and this is pod 2. So this would be like one network right here. So we could say this is, I don't know, Florida State University's network, right? And we have this one right here. Let's say this is, I don't know, Stanford University, right? And that's pod 2. Right? So we can have BGP if we really want to It's not really recommended, but you can have internal BGP between your routers internally. That would be considered iBGP, right? And then when you have a network that's out here, right, and we want to set up BGP, obviously we're going to do it over the backbone. We set up BGP between those two, that would be considered eBGP, or that's external BGP, right? That's the difference between the two. Now, when we scroll up, we'll see this is how this is the topology written like, how do I say? This is the layer 3 topology written out, right, with the IP addressing and stuff like that. This is the BGP topology. So same network, they just did it so that way you could see how the IP addressing looks. It'll just have too much. It'll just be too garbled. That's why they kind of separated the two, right? But it's the same network. They just showed you this is pod 1, AS1, right? And remember, BGP is separated in autonomous systems. So this group of routers, or university in this case, or business, whatever, their autonomous system, according to this map, is AS1. The other side is you guessed it, AS2, right? I know that's an ugly 2, but y'all know what I mean. Y'all know what the fuck I mean, man. All right, so let's go. What they said? They said to configure external BGP for autonomous system 1. You would need to configure a neighbor statement for each pod. A neighbor statement for each pod, right? So when we are defining our neighbor, you got to use the neighbor statement, right? So this is kind of I guess if you're new to BGP, this is like a new topic since we've been doing Ospf in the last couple streams, right? So we need to configure eBGP externally, right? And let's see. So this is AS1, right? And then this side is AS2. So we're going to configure BGP and then have this guy be our neighbor over here, right? So let's go ahead and do that. Let's go to P1R1, which is located over here. Y'all make sure y'all hit that like button. And make sure you subscribe to your boy. He said, oh yeah, y'all all said it, 2.240. Okay, cool. So to enable BGP, it's really similar to the other routing protocols that we've done on this channel, right? EIGRP and Ospf, right? So you just go to global config mode and then router and then the routing protocol, and then in this case the AS number, or autonomous system number, right? Because Ospf, that number is the process number, and then which is locally significant, and then with BGP we're working with ASs, similar to EIGRP. We're working with ASs, or autonomous systems. So BGP with question mark, you'll see what is the AS number. Well, in this case, our AS number is AS1 on this side. Ours, right? We are AS1. We're working on this guy right here, right? My AS is AS1, right? I'll show you again, right? We'll go to this map. AS1, right? This side is AS2, right? So remember that. So we do that in AS1, and then we'll be in, how we say, router config mode for BGP. So now they want us to define who our neighbor is in this case. So that's done with the neighbor statement. Neighbor, and then we put the IP address of the neighbor, in this case, P2R1, this guy right here, right? Is that what they said? Let me make sure. So yeah, what I was saying is make sure you subscribe to this channel, and then once I get to 5,000 subscribers, I'll be gifting away a copy of this application that I'm using, Boson NetSim, version 13, and I guess the menu button don't want to work right now. Yeah, I'll be giving away a copy of this once I get to 5,000 subscribers, and I've been saying that for the past couple streams, but that's because of some of y'all ninja watchers over here. But it's all good though. What was we saying? Configure. No, that's the wrong one. You will need to configure a neighbor statement. So configure. Oh yeah, let's do that. So the neighbor in this case is P1R2. We need to do configure a neighbor statement for each pod. The fuck? Okay, so the neighbor statement. We need the address for this guy, P2R2. Because I don't see why they did that, because they said right here. Okay, I see why. Let me look at that map. There's a neighbor. So his IP address in this case is 10.100.100.2. Right? And that's what they ask us right here. What's the neighbor's address? Right? We said is 10.100.100.2. Right? We question mark, and you'll see a whole bunch of options, right? Don't worry about all this other stuff until we get really deep into BGP. And BGP, I'll tell you right now, can be a really deep subject, right? Like CCIE level, like really, like it's the wide area network. This is the protocol that we use on the internet, right? And to this day, it's still pretty much the primary routing protocol on the internet. Some people don't even call it a routing protocol, but that's a whole nother subject or argument there. Remote AS is the one. This the command we need to worry about right here. Specify a BGP neighbor. In this case, the neighbor is going to be this guy, right? What's the remote AS? Remote autonomous system. The autonomous system that the neighbor is in, not us. We are in AS1, right? Like I said, we are in AS1. This guy is in AS2, right? That guy right there, he's in AS2. So now we can put AS2, and then that should define our neighbor, right? Now we can get on our knees and pray to the network gods and hope we become neighbors if BGP is already set up on this, which I think it is. Because that's what I like about Boson. A lot of this stuff is already half done for you, so you could just focus on what you need to focus on rather than, coming up with a whole topology, doing the IP addressing, even though we did some IP addressing, but et cetera, right? And then notice the syslog message right here, BGP adjacency change, and the neighbor is up. Who's our neighbor? 100.2. We are 100. What? We are 100.1. The neighbor is 100.2. So now we have a BGP adjacency between these two guys right here. Perfect, right? That's good to go. Now, what step was that? That was this part right here. You would need a neighbor statement to configure a neighbor statement. I mean, you would need to configure a neighbor statement for each pod. Oh, so, yeah, that's for eBGP, right? E, external. So configure a network statement for each directly connected network. Well, let's see. Let's see what directly connected networks we have. Show IP route, right? That's how we can see. Notice we got some BGP routes that we've already learned. That's good to go. That's good. Now, the directly connected networks are usually indicated with the directly connected right there. And then we'll see we are directly connected to this network right here. So we'll basically have to do kind of like what we do with OSPF with the network statements and advertise these networks through using BGP, right? So we'll do one for the that network, this network, and that network. Yes. So let's start off with this 10, 100, 100.0 network, right? So we go to global config mode, router, BGP. We said we are in AS1, right? And then the network statement for 10.100.100. What I said? .0. He said, where'd you get that iBGP is not recommended? Well, it's true in some cases, but there are plenty of valid. There are valid use cases, but for the most part, you're not going to use BGP internally all the time. You're going to use an internal routing protocol, but I see what you mean. There are just concerns with things like loop prevention that you can get around using RR, confeds, etc. So on a large enterprise network like a global company, would BGP work best in terms of network reliability using OSPF? Internally, probably not. You would use an internal routing protocol internally, and then externally you would use something like BGP. But yes, you can use an internal BGP, but you're not going to use that as your primary routing protocol for, like, let's say, your layer 2 network or something. Depends. They're not mutually exclusive. They are often used in tandem with each other. And if you're ever wondering why, I challenge you to take a topology of 50 routers and do routing with solely BGP. You will tear your heart out. But BGP is very, very stable and flexible, which is pretty much why that's the main routing protocol on the internet, right? You can use BGP to do IP version 4 unicast routing, VPS signaling, eVPN signaling, populating the you can do all kinds of shit with BGP. Yes, I know that. And like I said, it can be a really deep subject, but we're just doing basic stuff today. Network, and then the one thing I found myself doing is putting the subnet mask right after that, right? We said the subnet mask is /24, right? So 255.255.255.0. Press enter is going to say, what the hell? You missing something here. What? No, yeah. So BGP, you got to put the mask keyword there. I was doing that a lot back in the day. So you got to make sure you put the mask keyword and then the subnet mask, unlike EIGRP and OSPF. So the other network statement we wanted to do was 192.168. What was the other one? Let me scroll up. What was those networks again? 1.0/28 and 1.32/28, right? In this case, is that the other one we wanted? 1.0 for sure. And then is that the loopback? No, this is the loopback. So 192.168 1.0 for sure. So 192.168 1.0 mask is 255.255.255. What he said? 1.0 and so 255.0, right? Did I say what? Well, I forgot, man. I forgot. That's like /28. My bad. So that's supposed to be .240. So let's get rid of that. Click no there, and then put that back, but .240, right? Because of the /28. And then the last network statement we want to do should be this right here, which is the 1.32 network, right? And that was indicated over, what was that? Right there, 1.32 network. So one more network statement, 192.168.1.32 mask is, what was it, /28? Yes. So 255.255.255.240. That's all the network statements. It should be all the network statements. Display P1R1's BGP neighbors. How many neighbors are listed? How do we do that? Show IP BGP neighbors, I believe. Yes, neighbors. And then you see a wealth of information for just one freaking neighbor. Y'all know there's like I guess you could do show IP BGP sum to see a more concise output. But when you do BGP neighbor, you get like all this shit for one neighbor. Hold on. From here to there, right? So BGP neighbors. And who's our neighbor? 100.2. That's this guy right over. Let's say this guy right over here. Right? Give him a heart. It's 100.2, right? Remote AS is 2. Remote his router ID. How long he's been up for? 5 minutes of me talking shit. And we got some prefixes received and sent, etc. Right? Is that prefixes? I think. I don't know. Yeah, there's the prefixes right there down here. All this stuff, right? So anyways, we got just one neighbor. I don't know where they say how many there are, but definitely this is our neighbor. But is there one that just says how many neighbors we have? No. What do we do? Show IP BGP sum. Oops, BGP summary. This lets us know in concise information that we have just one neighbor right there, right? Yes. What else they wanted us to do? He said, oh, I got disconnected. I'm sorry, y'all. Y'all hit me that like button, man. Make sure you subscribe to your boy, too. I typically stream Monday through Thursday, 8 p.m. Eastern Standard Time, but lately I've been starting to stream at 9 o'clock because it's been a lot better for my schedule. I have yet to change the banner on my shit, and I have yet to make it solid. So what was the other thing they wanted us to do here? Display the IP BGP information. Do you see any BGP paths? I think we could just do that with show IP BGP, like that. And this is the IP BGP information, our local router ID. BGP table is 4. We got status codes, kind of like it's almost like show IP route. This is like a little legend. Once we start getting deeper with BGP, we see the valid path, which is this guy right here. All of these are valid. And then the best path for each network are indicated by that. Where the paths are they saying? They said, what else they want to know? Do you see any BGP paths? Well, these would be considered our paths, right? It's like the ISs. The ASs for pretty much everything in our path or hops. What else? Display detailed BGP neighbor status. What is the BGP state of the first neighbor? I would have thought this was detailed enough. All this right here, show IP BGP neighbor. What did they want to know? They wanted to know the BGP state of the first neighbor. What show command do you think you guys they're referring to? Oh, there it is right there. A state is established. And remember, there's how many states is there? Like 6 or 7? I don't know. It's like open, sent, established, and all that. There's a couple of them. I'm not gonna go too deep into them right now. I definitely need to go over them and review them. Do I have a spreadsheet for that or a cheat sheet? I'll pull it up later. I'll put it up in a little bit. What else they want to know? Verify eBGP by issuing a ping to P2R1's loopback 0 interface. The ping should be successful. So basically, they want us to ping from here to there, right? Issue a ping, and they're saying that it should be good to go. So let's go ahead and do that. Ping 192.168.2.1. Is that what they said? Yes. So ping 192.168.2.1. We got a reply, good to go. Where are we at now? Task 3. So we got 7 subtasks, and we should be able to wrap this up. We should be done. Configure iBGP on P1R1 and P1R2. So now we're going to do internal, right? Remember we did external between let's do this. Let's pick a different color. This was pod 1, all right? And this is pod 2. We already set up external BGP between these two, right? E. I'll put an E there. Now they want us to set up internal BGP between these two right over here, right? So internal, let's pick a different way to indicate that. Internal BGP between these two guys right here. So we're gonna make them two neighbors, and then go from there. We should be able to see each other's routes and stuff like that using BGP. On P1R2, enable Bgp. So basically the same thing we did last time, right? Yeah. On P1R2, so we got to do, but on the P1R2, so we got to go P1R2, which is that guy right there, right? In other words, this guy right here, and then enable BGP and configure a network statement for each directly connected network. So let's look at our networks. Show IP routes. We have this network, 1.16, the 1.32, and 1.48 networks. So we got to put network statements for each one of those. We go to global config mode, router, BGP. What AS we in? We're in AS1, right? AS1, remember? This is AS1 and this is AS2. And we're working on this guy right here. So he is in AS1, right? So he's in AS1. Now we do the network statements for these ones that we indicated in the routing table. 192.168.1.16. Subnet mask of /28. So 255.255.240. See, I did it again, man. Don't forget that mask keyword. I keep forgetting that. You know, I was working with so many we've been stuck with Ospf for like the past 3 or 4 weeks that I forgot in BGP you got to put the mask keyword. The next network was .32. And the next one is .48. So I could just change that last octet right there, right? .48, I believe, right? And it was all /3028. That last one is actually, yes. Okay, they were all /28. Okay, good. Good to go. On P1R1, configure a BGP neighbor relationship with P1R2. So now they want us to basically make these two guys neighbors, right? Now we already made them two right there neighbors. Hold on. Let me get rid of all this shit. We already made these two guys neighbors, right? How do we do that? We did that with the neighbor statement, right? Remember? We did neighbor and then put that IP address. And we said who the remote AS is in this case, right? Now we're going to create a neighbor relationship between them two right here. And then remember, but now we're using the same AS because we're both in the same AS. So let's go to P1R1, that guy right there that I moved. Go to global config mode. We say router BGP. We are in AS1, and then we're saying our neighbor should be this guy right over here. But we're going to use his serial interface since that's the next hop. 192.168.1.34. So 192.168.1.34. subnet mask of /28, so 255.2. Do you do the subnet mask? I don't think you do the subnet mask. No, you just do remote AS. So don't worry about the subnet mask in this case. The remote AS, we're in the same AS, so now we just put in a 1 here, and then get on our knees, pray to the network gods, and hope for a syslog message indicating that we're BGP neighbors now. He said, thank you for the explanation, Kevin and NetworkBruh. Most major companies most likely use a hybrid approach. Yes. Yep. It's all about using the right tool for the job. ISs. I see this guy has been labbing IS. Yes, sir. Yep. Let's see. We did not get a neighbor yet. Does anybody know why? We put our neighbor statement to say that this guy over there is our neighbor. Right? Why didn't they become neighbors just yet? Why did they not become neighbors just yet? So these two right here are neighbors. These two right over here. This guy and that guy. Then we said, hey, I have a neighbor. His name is P1R1R2. And that's his IP address. Let's become BGP neighbors. I'll give you a couple minutes to get that. Anybody know why? I know Kelvin knows why. He's just ready to blurt out the answer right now. What else we got on the agenda on the news today? Let's see what data leak we have or some kind of breach do we have today, right? That's all I've been reading on the current events here, right? Epic Data, y'all remember that Epic Data breach that we talked about last week, where they basically leaked a whole bunch of information of like some alt-right, members and a whole bunch of like, I guess, right-wing people or whatever. Epic Data breach impacts 15 million users, including non-customers. That's crazy. Scraped who is data of non-Epic customers also exposed in a 180 gigabit leak. And y'all remember the group Anonymous? They the ones that leaked that information. Epic has now confirmed that an unauthorized intrusion did in fact occur into its systems. The announcement follows last week's incident of hacktivist collective Anonymous leaking 180 gigabytes of data stolen from an online service provider, Epic. To mock the company's initial response to the data breach claims, Anonymous had altered Epic's official knowledge base as reported by ours. That's crazy, man. Shout out to Anonymous for that, but they are kind of putting people at risk with that information. But either way, Epic is a domain registrar and web services provider known to serve right-wing clients, some of which have been turned down by more mainstream IT providers due to the objectionable and sometimes illicit content hosted by the clients. Epic's clients have been included in the Texas GOP, Parler, Dab, and 8chan, among others. Womp, womp, womp. So yeah, what we are missing here is another neighbor statement saying that this guy is our neighbor. So that's what we got to do. We ain't have to do it on this one because it was pre-done for us. That's what I love about Boson NetSim. Sometimes they do half the work for you. The other half they say, go ahead and figure it out. So let's go to this guy and put that other neighbor statement declaring that P1R1 is our neighbor. So we're already in global config mode or router config mode. So now we just say neighbor, neighbor is going to be this guy right here. We'll use his serial interface. So 1.33. The neighbor is 192.168.1. Come on, man. .1.33. Mask is, no, we ain't got to do the math. My bad. Remote AS is the same AS. So in this case, 1. Now we should theoretically form a neighbor. Let's get on our knees, pray to the network gods, cross our fingers, and there it is. We got an adjacency change. Neighbor 1.33 is up. Who is that? 1.33 is this guy right here. So we can give him a green circle. We're good to go there. So now these two are neighbors. What else they want us to do here? Configure a BGP neighbor relationship with P1R2. which we did. And then on P1R2, configure neighbor BGP relationship with P1R1, which we just did to make them neighbors. On P1R1 and P1R2, display summary BGP status to verify the neighbor relationship. Summary is my favorite command. Show IP for BGP. Show IP BGP summary. And that just gives us like, real quick information about the BGP status. We see right here the router identifier. So the router ID basically. Who is the router ID? There's this guy, 1.17, I think, right? Is that who's 1.17? What the fuck? No, that's me. My identifier. I'm on P1R2. So this guy right here, that is my identifier. So that's my router ID. Right? That's my router ID? Yes. Yeah, because the router IDs are the loopbacks. The local AS number, which is 1. BGP table version is 4. Main routing table is 4. Then we have the neighbor 1.33. Who's that? That is this guy right here. What else? The table version number, the AS number, how many prefixes we received, I believe. This is table version number. I think this is queuing. How long it's been up. We refresh real quick. We'll see it's been up for 1 minute and 30 seconds. And then prefixes we received and sent. So, y'all got any questions so far or anything? Y'all let me know if y'all have any questions, or I know this is basic BGP lab. We'll get a little deeper in a little bit with BGP pretty soon. I think maybe we could crack open that lab manual and start working with some deeper BGP stuff. They wanted to display the neighbor table on this guy as well. So, and notice we got the syslog mentions on that side too. Show IP BGP summary. We'll see my router ID is 1.1. What is that? That is my loopback. 1.1. Local AS, same AS, because it's internal, right? The BGP table. He has 2 neighbors. Notice he has 2 neighbors. This guy only had 1 neighbor, right? See, watch. He got 1 neighbor. He got 2 neighbors. Who is that? That's this guy, and that guy is his neighbor. That's why he got 2 neighbors in that output there. The prefix we received. Queuing, how long it's been up? 20 minutes for that one, 2 minutes for that neighbor. That's pretty much it for that. What else? I think just 2 more show commands and we should be done. And a ping. Display the routing table. Does a route exist to the P1R1 loopback network on P1R2? So we got to go to this guy right here and see if we can see his loopback network right over there. So we go to P1R2, which is over here. We do a check his routing table, show IP routes. And the network is what? 192.168.1.1 network. Network, rather. There it is right there. And we learned it via BGP, right? Because it's not directly connected. So we learned that using a routing protocol. The administrative distance is 200. That's how many, this is the metric. How many hops away, I think? No, just 0. I don't remember. What's the metric? Oh, there's so many metrics for BGP. What am I thinking? It's learned the that next hop, how long we learned it for. What else they want to know here? What is the next hop IP address to the routes for pod 2? So here's pod 2 right over here. Right, we said this is pod 2. Use a different color. This is pod 2. What is the next hop? So the next hop from pod 1 should theoretically be somewhere down here. What is the next hop? That address right there, 100.2. So and usually in pod 2 is indicated by these networks, the 2.50 network, 2.49, 2.17, 2.34, the 2 dot network, right? We notice these are the 1 networks. Scroll down some. Here's the 2 networks. What is the next hop? 100.2, 100.2, 100.2. 100.2. What is that? That is this guy right here. So that is the next hop. On P1R2, which is this guy right over here, ping P2R2's loopback 0 interface, 2.17. The ping should be successful. So they basically want us to ping from here to here. Send a ping all the way across, and it should be successful. Now that we've got some routes to that network. Ping 192.168.2. 2.17. We got a reply. Good to go. We press Control G to grade the lab, right? Or we can, the menu's fucked up, so we'll Control G. And right here, you completed a lab successfully. Click OK to view the results. So we're good to go. Once we see all check marks like this, that's what I love about Boson NetSim. It grades your work and stuff like that. So if you're missing anything or you fucked up somewhere, it'll tell you. And you'll see some red X's over here. So I guess we pretty much did the lab and we completed it successfully. So we good to go there. If you missed the stream, go ahead and hit that replay button. I typically stream Monday to Thursday, 8 p.m. Eastern Standard Time, but lately I've been streaming at 9 o'clock. So make sure you subscribe, hit that notification bell so you know exactly when we're going to stream. I'll be gifting away a copy of this application so y'all could do it with me, along with me, once I get to 5,000 subscribers. So help me get to 5,000 subscribers, man. And I'm going to gift this application away so we can do it together. So that way, if I mess up somewhere, y'all can be like, no, man, you messed up a router too. That's the reason why you didn't complete the lab. And I was like, oh, okay. Because I get a lot of help from y'all and vice versa. So it makes it a better learning environment for us. And for some people that are kind of shy, they don't, they just kind of lurk around. They could just see us kind of discussing, and it helps us learn. It creates a much better learning environment, man. So also, make sure you join the Discord server. Here is an invite. So if I do make a change to the schedule, like if I cancel today's stream or if I'm like too tired from work and shit, I will let you know in the Discord server and say, hey, I'm not streaming today. Or if there's an extra stream on the weekend, I'm like, I'm gonna stream today. Press the record button. I start recording and do an extra lab on the weekend sometimes. The only way you'll get that inside scoop is if you join that Discord server and you'll know. So tomorrow, I guess we'll do another BGP lab, maybe from the Encore manual, maybe. Or maybe from Boson NetSim. Who knows? What other BGP labs is in here? I can't remember. Let me close this up. Where is it? See, that menu's not even in here, man. Grade, save. See, I got to restart the application. I don't feel like doing all that right now. Yeah, I don't feel like doing all that right now. So we'll do it. We'll do another BGP lab. Maybe it's a basic one. Maybe we'll do one from from the lab manual. Who knows? Anyway, for now, comment, like, subscribe to the network.
Bruh.